Hi everyone, welcome back to the Saga Tech Gates. So in today's videos, we are diving into an important concept in Verilog, sequential and parallel blocks. So when we write a Verilog code, especially for simulation, not only simulation but also for modeling, understanding how statements are executed is crucial. So Verilog provides two powerful ways to control execution flow. So begin end for a sequential execution and where the statements run one after another, and another like a fork join for parallel execution where statements run concurrently. So knowing the difference between these two can help you write more accurate test bench and debugging timing related issues and also improve your simulation efficiency. So let's dive in and see how Verilog handles a sequential as well as a parallel execution with simple examples you can try right now. So coming to the sequential and parallel blocks. So block statements are means of grouping statements together. So they act syntactically like a single statement. So the block of statements means we are grouping a few statements. They act like a single statement in a Verilog. What is mean a statement? So anything that end with a semicolon known as a statement. So there are two type of blocks in Verilog HDL. So one is sequential block, also known as a begin end block. So the statements run one after another. If you write a few statements in the sequential block, so all the statements will execute one after another. Nothing but a sequential execution. So whereas another block we have parallel blocks, also known as a fork join block. So all the statements run at the same time. The statement written in the parallel blocks will execute concurrently. So coming to the sequential block, so the keyword begin and end are used to group statements into sequential block. Clear? We are using these two keywords, begin and end. So not only here, if you remember, so in the previous video also I explained, if anything, if you write between begin and end, all the statements known as the sequential statements, they will execute one after another, the order in which they are written actually in that a block. So the procedural statement in a sequential block should be executed sequentially in the given order. So all the statements, okay, in that begin and all execute sequentially, so in the given order, so in which order we are written in that, okay, so in the same order they will execute. So a sequential block shall have the following characteristics. So the sequential block have some following characteristics. So statements shall be executed in sequence one after another, so that we can call as the sequential block. Clear? So the delay values for each statement should be treated relative to the simulation time of the execution of the previous statements. So in the sequential block, so delay values for each statement should be treated as relative to the simulation time of the previous statements. So we'll see some example, okay. So control shall pass out of the block after the last statement executes. Okay. So when that control come out of that block, so if execute the last statement in the sequential block, then control shall pass out of that block. See some example here. So sequential block without delay. So I'll declare two variable as a reg type, reg x comma y. So reg 1 down to 0 z comma w, this 2-bit variable z comma w. So initial begin x is equal 1 tick b 0. Now here begin and end, these are the sequential statements. So these statements will execute one after another. So first it will execute x equal 1 tick b 0, we are assigning a 0 to the 6. After completion of this statement, then we'll go to the next statement, then y equal to 1 tick b 1. After completion of this y equal to 1, then we'll go to the z. This simple concatenation operator, already we discussed, please visit that video if not. So z is equal x comma y. So similarly w is equal y comma z. After completion of this statement, there we're executing these statements. So all are the sequential statement. So I didn't specify any delays here. So now if I specify delays to this each and every statement, now let us consider here sequential blocks with delays. So now the same example I consider, but I added here some delays. Okay, we know that how to represent delays in a Verilog by using a hash. So now x equal 1 tick b 0. So you remember that all procedure blocks, nothing but initial and always will start at 0 simulation time only. Clear? Now all initial blocks will start at 0 simulation time. Assume that this is the first statement in this initial block. There is no prior delay here. So now this will execute at simulation time 0 only. So this x equal to 1 tick b 0 execute at a simulation time 0. After that we need to wait. So 5 time units. 5 time unit steps here, hash 5. So y equal to 1 tick b. This statement completes at the simulation time 5 only because we are specifying the delay 5. Now here I'll write hash 10 z equal to x comma y. This statement complete at the simulation time 15 because the delay here, relative delay to the previous statement. Here the delay is 5, 5 plus 10, 50. So now we are adding this delay to the statement because all are in sequential. It required 5 time unit step to complete. Okay, so now here 5 time steps, here 5 time steps, so total 15 time step. So this statement will complete at the simulation time 15 only. Now coming to this statement, here hash 20. W is equal to y comma x. So this statement complete the simulation at time 35 because till now we required a 15. 15 plus 20, so 35. So to complete this statement, we require a 15 times. So this statement complete at simulation time 15. So relatively we are adding up to the right. See, this 10 added to this 5 added to 10. So here this 5, 10, 20 added to this statement. Clear? So coming to the parallel blocks. So parallel block should have delimited by the keyword fork and join. Remember, fork join is used only for a simulation purpose. It is not synthesizable. Clear? So this fork and join is only for simulation purpose, not synthesizable. Remember that point. Clear? So now the procedural statement in the parallel block shall be execute concurrently. All will start execution at the same time. Right? So now the parallel blocks have the following characteristics. So now see, statement shall execute concurrently anyway, so that we can call as a parallel blocks. Okay, so we are using fork and join keywords here. So delay values for each statement should be considered related to the simulation time of entering the block, whereas in the sequential block it is the previous statement related to the simulation time of the previous statement. But in the parallel block, the delays, okay, consider related to the simulation time of the entering the block. All statement will execute concurrently. So at which time that block will start execution, that is the actual relative simulation time. So we'll see. We'll discuss with some example. Now delay control can be used to provide time ordering for assignments. So we are providing, for example, in my parallel block I have a 5 statement. I can provide, okay, this statement will execute at 5 simulation time, this statement at 10 simulation time. So I can provide the time ordering for assignment also, at which time I need to execute that statement in the parallel block. So control should pass out of the block when the last time order statement executes. So where in the sequential block, after execution of last statement, so control should pass out of the block. Whereas in this parallel block, so the control pass out of the block when the last time order statement. For example, I have a 5 statement. So I mentioned one time, one statement will execute after 30 simulation time. So that is the last, that is a provide highest time delay. So that is the last statement in the parallel block. Clear? So in that case, after executing that, then control should pass out of that block. So we'll see some example, then you can understand. Now in this example, right? So same example I'll take here, but in earlier case I'll take begin end, but here I'll take fork join. That is the difference. Clear? Here see, this is a fork and join. So now raise x comma y, raise 1 down to 0, z comma w, initial fork and join. So x equal to 1 tick b 0. What are these fork join block known as a parallel block? All the statements written in these parallel blocks will execute concurrently, nothing but parallelly. Clear? So now here, this statement started 0 simulation time because I didn't specify any delay here. So now this x equal to 1 tick b 0 will execute at 0 simulation time. Whereas this statement completes at simulation time 5 because I'll provide a time unit delay, how much? 5. Clear? So for this statement, I'll provide a 10 time units delay. Okay, here 20 time units. Clear? So all will execute concurrently. So it takes 0 simulation time to complete. So it take 5 simulation time, it take a 10 simulation time, it take 20 simulation time. I hope you understand because all the statements start at exact same time. but individually we are providing some delays so that it will take 5 time minutes delay, it completes at 10 simulation time delay, it execute at simulation time 20. Whereas in the previous case, to execute this we required 5 plus 10 plus 20, 35 simulation time. It will complete at the simulation time 35, but here it completes at the simulation time 20. I hope you understand. Now see these two example, right? And moreover, in this case, so what is mean process actually? In Verilog, the term process usually refer a block of code that execute sequentially in response to some event. Okay, so especially the statement written in begin and ends process, right? Now see how many process here. So sometimes if there is no begin and end, the single statement itself is a process. Clear? So all the process in the fork start at the same time and run concurrently. Now, so this is a one process. This is a one process. Okay, right? This is another process. This is another. Here we have a 4 processes in the fork. All will start execute at the same time, but we are specifying the intentionally these delays, right? I hope you understand what is the meaning of process. So process usually refer to the block of statement or codes that execute sequentially. So in response to some events, especially we are okay written in begin and end. If for example single statement, there is no begin and end. Single statement itself is a process. It is also one process. Clear? So we'll discuss okay with some example also, right? So now you should know what is mean statement, what is mean expression, what is meant by process to understand this sequential and parallel blocks, especially for parallel blocks. So now here are both same example I mentioned here. Just okay, pause the video and try to understand. Okay, just now I discussed these two examples, right? So now it completes at 0 simulation time. It is also complete 0 simulation time. Clear? In the fork gen, all will start at the same simulation time. Okay, so it will one after another. It will execute parallelly. All can run concurrently. So now it will execute, it completes at a 5 simulation time, it completes at 10 simulation time, it completes at 20 simulation time. Whereas in the sequential block, so it complete this assignment, after that we go to the next statement. Now it required 5 simulation time, then it completes. Okay, after that we go to this, and to complete this we require 15 simulation time, 5 plus 10. After completion of execution, okay, then we are going to this statement. Clear? So it required 35 simulation time to complete this. Just one after another, here all will execute concurrently. Now see in this example, so just now we discussed a process. What is mean process? Process refer to the block of statement that execute sequentially in response to some event, right? Now see here, we can this statement written in begin and end. For example, there is no begin and end. That single statement itself is a process. Now if you see here, initial, begin, end. Okay, initial, begin and end. So what is the meaning here? So that statement written in this begin and end execute sequentially, as we discuss as of now. But we have one more. So parallel blocks inside this begin and end. Fork and join. So now what happened? We have a 2 process. This is a 1 process. Okay, so the block of statement execute sequentially. Okay, written in begin and end. This is known as a 1 process, and this statement, okay, single statement itself is a 1 process. This fork join as a 2 process. Okay, one this process and this one. You can say threads also, right? So now first, if we try to execute the order of the statement, so first we'll anyway begin and end. It is a sequential statement. So first we'll execute #10 data. So it will execute first. After that, so the fork and join has a 2 process. So one is this statement, another is this block. Okay, we have 2 process. Now here we are fork 2. Clear? So here first we'll execute at the what simulation time? 10. So here 10 simulation time completed. So we are adding this at 10. 10 plus 10, right? Anyway, so 10 plus 10, we are at 20 simulation time. So now it will execute these statements. At 20 simulation time, we'll complete this one. Now we are entering into this. This process and this process will execute concurrently. Understood? So this is the one process, and this statement is itself is a one process. Now parallelly this statement and this process will execute concurrently. Now it required a 20 simulation time. Okay, it wait till 20 simulation time, nothing but 10 plus 20, 30. It will till wait 30 simulation time, because after completion of this only we are entering into this fork join. Clear? So this statement will execute at 30 simulation time. So now after that, so after completion of this statement only will execute this statement, because begin end. Begin end is the sequential block. The statement written in this begin end will execute sequentially, in which they are written. Actually, after completion of this statement only, we'll execute this statement. So now we'll complete this statement. After this, we'll state. So now, if I ask how much time to required to complete this, now tell me. Here 10 anyway. After that, how much time it required? So now here 20, 30 plus 30, 60. Yes or no? Right? So now anyway, after completion of this only, we'll enter into fork and join because it is a sequential. So he required here 10 simulation time. So now here these two are parallelly. So anyway, this started here, and here also this block, this process started here. It required 20 plus 10, 30, and also it required 30 plus 20 plus 10, 60. At the simulation time 60 will complete this one. So why it is a fork join now? See, if you see it like a fork, if you observe the fork, okay, having like this, a certain fork like this. Clear? So now that is the reason we can call as a fork and join, right? So both a sequential and parallel blocks can be named by adding name of the block after the keyword begins at fork. Clear? So now here a module, we have a two blocks, okay, two blocks. This is a one initial block, this is another initial block. Clear? Anyway, so here one begin and end, here fork and join. So in that, this is the one sequential block, this is a parallel block. So we can write a name of the block. We can assign some name to the each block. Here block 1 and block 2. Where? After begin, after fork. Clear? Now see, the name of the blocks serves as a several purposes. Why we need to assign names to each block? We'll see. So local variables can be declared for the name of named blocks. So what are the variable here? I is local to this block 1 only. Clear? So named blocks are part of the design hierarchy. So variables in the named block can be accessed by using hierarchical name referencing. I'll show some example, then you'll get an idea. So named blocks can be disabled. That means their execution can be stopped. We can stop some blocks also. Okay. So block of execution can be stopped by using some constructs, right? So now all variable must be static and with a unique memory location, and their values remains unaffected when entering or leaving the blocks. So those are the static variable, okay, and a unique memory location we are assigning to store that value. Their values remain unaffected even though we are entering or leaving the blocks. Now see here, this is a block 1. The sequential block named as a block 1. The integer I is a static and local to this block 1 and accessed by hierarchical name. So this is a hierarchical name. So what is that model name? Top. What is the block name? Block 1. What is the variable? 1. So top dot block 1 dot I. This is the hierarchical name we are assigned to this variable I. We can access this variable by using this hierarchical representation, right? Same way here block 2. It is a parallel block named as a block 2. The register I is a static variable and local to the block 2 only, and it can be accessed by using hierarchical name. So top dot block 2 dot I, like that. So now these are the two different variables. Now this is static to this block, this I is static to this block. We are using a separate memory location to store this I and this I. Don't think that both are same. Understood? So these are the static variable. So how can I access, for example, I want to access this I, then top dot block 1 dot I. Whereas if I want to access this reg I, then I'll use top dot block 2 dot I. This is a hierarchical name we are providing. This is the advantage by using these blocking names. So till now we saw how begin and helps us to execute a statement one after another, while fork join allows multiple statements to run in parallel. So it is a powerful tool in a test bench and a simulation. Just remember, a fork join is not synthesizable, so it's mainly used in verification environment, not in actual RTL design. So we never use this fork join in actual RTL design. So if you found this video helpful, don't forget to like, share and subscribe to Sagar TechGate for more Verilog and VLSI content. Got any question or want more examples, or drop a comment below. So thanks for watching and I will see you in the next video.